Okay, so here we are again, people. These are my new toys. You wonder what toys? You know, I bought me a whole pack of lithium batteries from a Mitsubishi Outlander. It's like 12 kilowatts of lithium batteries, and they are in packs like this. Okay, so there are 16 cells in each of this pack. 1, 2, 3, 4, 5, and the packs are looking like this inside there. These are the lithium elements, and here we had a BMS. So here is something about these batteries. There are LEV40 LEV40 8 with 1140 watts hour, 1.14 kilowatts per hour, made by gsuasa.com, and that's a really serious stuff. You know, these are automotive batteries, and they are really great, no doubt. Pretty heavy, and so far I know that these batteries have been drove for 93,000 kilometers, and the capacity reported by the onboard computer, it's around 64%. So we have 36% of lost capacity, but that doesn't really matter, because such a huge pack I can afford. Even if it's half, you know, if I have 6 kilowatts, it's more than enough to use it with my MPPT here. This one will charge the batteries, is going up to 60 amps, and it have a menu for lithium batteries. And then this guy will be connected straight to the batteries, you know, having power all the time. So in fact, this is the project. These batteries will be always charged by the solar panels, and from the output of all this pack I'm gonna power the inverter connected to the grid. I'm kind of in doubt for you know, how much I'm gonna charge these batteries, because I don't want to push them too much. Anyway, it's a huge difference the way they've been abused in automotion, you know, environment. The currents there are much higher than the ones I'm gonna need it, because this inverter of mine, it's only provide like 900 1000 watts maximum, and if I have like let's say 48 volts, it will be around let's say 25 amps maximum. And you know, it's a joke for these batteries. It's a joke. You know, guys, what I have to do the first, you know, I checked already for voltages, and they are exactly the same. Each cell is very well balanced. What I'm going to try to do now is to charge one of the cell. Okay, I'll tell you later about that. And of course, I checked the internal resistance of the batteries. So this one, first one here, and there is another one here. Oh, so I think he checked the elements, so it's not exactly tied. Okay, let me do this too. Anyway, it needs to be dismantled, so this shouldn't be a problem. Once again, first guy, yeah, now we are talking 1.05, 113, 1.12, 1.15. I'm talking about milliohms here, people. 1.14. Yeah, they are very okay. Just want you to see this. 3.13. Okay, same story here. Yeah, it's open. You know, believe me, I know what I'm doing, so it's very dangerous to work with any metal tools around this kind of batteries. They are so powerful. Okay, this guy here, oh yeah, 128, 113, but I think this one needs to be tied better. 129, 113. So the untouched ones, 120, 123. Okay, so I may say that the untouched ones, 119. Maybe that needs to be tied a little bit more. Oh yeah, 114 here, very clear. 108, 119, 112. Yeah, I never encounter this kind of low resistance. I hope they are okay for my future project. You know, I think that's it for today. Okay, so here we have one of the BMSs from the battery, from one of the battery, 8 elements, and here is very clear. We have a kind of balancing parts. So I'm really curious. This is a kind of passive balancing, because you know it's simply resistors and probably these guys, but I don't see any power transistors around here, you know, to move the capacity or the voltage or the extra voltage from one cell to another. And that's why I'm gonna charge one of the cells with a different voltage, and then I'll put this back, and we have to see if it's leveling the voltages. You know, that should be interesting, because if it's so, then I can keep it in place, doing the job, doing the balancing. Okay, so here I have my charger. That's 210 watts, 10 amps antimatter charger. This is the power supply, and I have one of the cells in the middle, you know, hooked on. And now let me put it to the maximum, because these are really heavy cells, so I'm not worried about you know, extra charging, supercharging or anyway. Okay, 10 amps, come on. Okay, so like I said, I'm going to charge one of these elements, one of these cells, and then I'll put back the BMS in here to see if it's doing the balancing by itself or it needs some extra electronic. Because if it's balancing, auto balancing or something, you know, like a pure resistance or resistive balancing, then it's really helpful. I don't need a BMS anymore, because all the other stuffs, you know, the voltage input, the voltage output will be carried by these two devices. Okay, I think that's it for today. Nothing else to do, but at least I checked a little bit the internal resistance. So they are around 1.1 milliohms. It's very nice internal resistance, beautiful, I may say. And I'll see what I can do further, how to put them together, what kind of configuration and any other kind of stuff like this. Thank you for now. I'll be back with some more as soon as the project it's you know, developing, as soon as the project evolves. And okay, I hope I'm not burning anything around. Thank you for now. See you soon. Bye bye.